Hello and welcome to section 3.5. And as you might suspect from the title of this section, we are going to learn the derivatives of the trigonometric functions in this section. So we're going to jump right into a graphical exploration here. So graph-based look at the derivative of a trig function. And we're going to start by sketching the function y equals sine x on the interval from negative pi to 3 pi. Okay, so let's start that out here. Got some grid lines, and I'm going to make our full height here be 1 unit, 0.5 there. Okay, and let's mark off some markings along our x-axis here. We want to make sure we include the interval from negative pi to 3 pi. Okay, so looks like I'm going to go with just, that's pi, 2 pi, 3 pi there, and then there's negative pi there. Okay. Now for our sketch of the sine curve, remember that sine starts at 0. And then at pi over 2, we have a sine of 1, back to 0 at pi, down to negative 1 at 3 pi over 2, and back to 0 at 2 pi. So that's one period of the sine function, just in case you need that little refresher from trig. Okay, there's our nice sinusoidal curve. And then we could repeat that shape for subsequent periods. Okay, we don't need to do a whole lot more here. I'll just go a little bit more in this direction. Boy, that's interesting. It should be a little curvier. Okay. There we go. All right, I'm happier with that. Okay, so there's a graph of the sine function from negative pi to 3 pi. Okay, step 1, complete. Now, step 2, where does the graph have horizontal tangent lines? Okay, so that's places where the derivative is 0. Okay, so horizontal tangent lines. Let me put some of those in really lightly here in blue. Okay, and notice how, on the portions of the curve in here, that is decidedly not a horizontal tangent line. Okay, that's not what we're looking for. Horizontal tangent line would show up like here. Okay, whoops. I hit something wrong there. It would show up down here. There's a nice horizontal tangent. Here's a nice horizontal tangent. There's one. And those are the only ones that are going to show up on this portion of the sine graph. If we kept going for more periods in either direction, we would get more horizontal tangent lines, but that's what we've got for right now. Okay, so what are the slopes of the tangent lines doing in between those values in step 2? To identify the values, since I guess we didn't here, we could say that those horizontal tangent lines are occurring right here. That'd be pi over 2. Right here, that's 3 pi over 2. Okay, right here, 5 pi over 2. And we also have one in the negative direction over at negative pi over 2. I'll just put ... since we could include more if we went out further with our sine function, but yeah. There's the 4 we've got. Looks like odd multiples of pi over 2 there. And yeah, now we can look at step 3. What are the slopes of the tangent lines doing in between those values? Okay, so we'll notice, I'm going to kind of break this up between our horizontal tangent values here. And notice that in this interval here from negative pi over 2 to positive pi over 2, our tangent line slopes are all going to be positive in there. Okay, so those are all positive tangent line slopes. Okay, so positive slopes. And in contrast, if we look on the next little interval there from pi over 2 to 3 pi over 2, the tangent line slopes in that interval are all negative. Okay, they're all doing things like this. Okay, so we've got negative tangent line slopes in there. Negative slopes. And then that pattern repeats again. On our next interval, we have positive tangent slopes. As the graph starts increasing again there. And then, you know, we could say there's some negative out here and a little bit of negative out here, but basically the slopes are alternating positive and negative in between those values where we have horizontal tangent lines. Okay, so we've got that. And in step 4 here, we want to incorporate the information from steps 2 and 3 to sketch a rough graph of the derivative function. And for convenience's sake, we can assume that the greatest positive value of the derivative is 1 and the greatest negative value is -1. Okay, we'll see how that comes into play here. All right, so first thing we want to start with is this idea here from step 2, horizontal tangent lines. Okay, that means the slope of the tangent line equals 0. We know that. And so since the slope of the tangent line is 0, that means the derivative is 0 at those points. Okay, so that's a good starting place here. Anywhere there's a horizontal tangent line on the original function, the derivative function is going to have a value of 0. So at pi over 2, 3 pi over 2, 5 pi over 2, negative pi over 2, the derivative will pass through those points. Okay, now to incorporate step 3, what are the slopes of our tangent lines doing in between those values? That tells us what the values of the derivative are doing. Okay, so values of the derivative represented by those slopes of tangent lines. So for instance, here, where we have positive tangent line slopes, that's really indicating for us now that there's going to be positive values of the derivative. So positive derivative, okay? And you'll notice that, okay, if we start out here at x equals negative pi over 2, we have a tangent slope of 0. And notice that, yes, it is going to have a positive tangent slope, positive derivative value right after that. But it's not a very large positive value. Like our tangent line slope might be something along those lines, okay? Not very steep, so it's not a very large positive slope, pretty small positive. So we might put a small positive value right there, okay. But then that value starts increasing because the slope or the steepness of that tangent line is going to increase pretty quickly, all right? Our next tangent line we might draw might look something like that, okay? A larger positive, an even larger positive. Okay, so this is just increasing there. And it looks like we are probably going to have our steepest tangent line slope right in the middle of that interval. right here is about as steep as it gets. So we'll assume that we hit our greatest positive value of the tangent line slope, or greatest positive value of the derivative. We'll hit that 1 at that point right in the middle there. Okay, so our slopes are positive, they're increasing up to that value of 1. And then they're still pretty steeply positive here, tangent line slopes, but they are going to start getting less positive, okay? They're going to start flattening out again as we start to approach the next horizontal tangent line. So, oops, I just made the graph disappear. But they are going to start being less positive, so they start decreasing. Okay, until we get to the next horizontal tangent line there at positive pi over 2. Okay, so you might kind of see the idea there. Start out small positive, increasing positive value. We hit our largest positive tangent line slope, and then the tangent line slopes start decreasing again, less and less steep, but still positive until we get back to 0. Okay, kind of a lot going on in just a little segment there. Okay, now the next segment here, we're going to do essentially the same type of thing, but now the tangent line slopes are all negative. So our values of the derivative are going to all be negative. Okay, and yeah, they start out negative, but not a very large negative, not super steep. Okay, so a small negative value, but they are going to start getting steeper, more and more negative, until it looks like, again, right in the middle of that interval, we hit our steepest negative tangent line slope. So that's our greatest negative value of the derivative. We're told that that is -1. So we're going to hit -1 down here. And then after that, we continue on with pretty steep negative slopes, but then they start getting less steep. Still negative, but they're going to be smaller negative numbers because it's a less steep slope. So they come back towards 0 until we hit the next horizontal tangent line. Okay, and so you can follow that same type of pattern to fill in the rest of our derivative graph in green here. From 3 pi over 2 to 5 pi over 2, we're going to follow the same pattern that we saw right here between negative pi over 2 and positive pi over 2. So it's going to make this type of shape again with our positive tangent line slopes up to the greatest positive value and back down. And then for this last little segment here, we have negative, whoops, gotta watch my erasing on this. We have negative tangent line slopes there. And so we'd end up with something along these lines. Okay, down to our greatest negative value. Same thing over for this little segment here. That also has negative tangent line slopes. Okay, but it's starting at the steepest negative right here. Okay, and then we come up to that 0. All right, so again, the black graph here, that is y equals f of x equals sine x. And the green graph that we've now constructed, that's the derivative, dy dx, or f prime of x. And so we got to think about what function that looks like. And if you just kind of ignore the black graph for a second and see what the shape of that curve is, our green graph kind of around the intersection of our axes here, it does something like this. Okay. Up to a maximum value of +1, we have the point 0, 1, and then it oscillates off from there. This that we're looking at is actually the graph of cosine. So that turns out to be the derivative of the sine function. The derivative of sine x is cosine x. And that's one way that we can see it, is with this graphical approach here.